All right, in this video, we're going to look at some examples of simplifying logarithmic functions and expressions. So example one, we're going to simplify each of the following. So first up, we have log base 3 of 81. Now, when you're evaluating something like log base 3 of 81, what you're really trying to ask is what power do I have to raise this 3, this base of 3 to, in order to get this value here, the 81. So anytime you're evaluating a logarithmic expression, what power do we have to raise the base to in order to get what we're taking the logarithm of? So 3 to what power gives us 81? Well, 3 to the fourth power will give us 81. So log base 3 of 81 is 4. So in other words, if we take 3 and raise it to the fourth power, we'll get our 81. So we can write this in exponential form as 3 to the fourth power equals 81. Now, most calculators will be able to evaluate this for you as well. So for instance, in Desmos, if we want to evaluate log base 3 of 81, if we go into our keypad here and under functions, go under miscellaneous, and we see a couple logarithmic functions here. We have ln for our natural log, we have our common log base 10, and then we have this log base a, which will allow us to type in whatever base we want. So we select that. Now it's waiting for us to select what base we have. We have log base 3, and then we can arrow over inside parentheses of 81, and it gives us 4. So that's how we can use Desmos to evaluate logarithmic expressions. All right, part B, we have log base 2 of 1/8. So once again, in other words, what power do we have to raise 2 to get 1/8? And 2 to the negative third power is 1 over 2 to the third power, or 1/8. So we have to raise 2 to the negative 3 power to get 1/8, which means log base 2 of 1/8 is negative 3. Remember, your domain, what's inside these parentheses here, must be greater than 0. But for logarithmic functions, your range is all real numbers. So we can get back negative numbers in return. We just can't evaluate logarithms at negative numbers. Once again, if we wanted to use Desmos for this, log base 2 of 1/8, we can just quickly change this here, and then delete this, and then type in 1 and an 8. And it should come up negative 3, and it does. So awesome. All right, next up we have log base square root of 5 equals 25. So what power do we have to raise the square root of 5 to get 25? Well, we could try this out a little bit, and eventually, if we try 1, we'll get the square root of 5 back. If we try square root of 5 squared, we'll get 5. Eventually, we'll get down to the value of 4, which is what the correct answer is. The log base square root of 5 of 25 does equal 4. We can even type that in on Desmos as well. If we go functions, and we can even put in square root of 5. As long as the base is positive and not equal to 1, we should be good to go. And 25, and there's our 4 again. So, all right, part 2, we have the natural log of the cube root of e squared. So for this one, we're looking at rewriting the cube root of e squared as e to the 2/3 power. Remember, when going from radicals to rational exponents, it's power over root. So e to the 2/3 power. That's log base e of e to the 2/3 power. And one of our properties from a slide in the last video was if the base of our logarithm matches what we're taking the same as the base of what we're taking for our exponential expression here, then the answer is going to be the power. So in other words, what power do we have to raise e to get e to the 2/3 power? It has to be 2/3. So the natural log of the cube root of e squared is 2/3. We can see that in Desmos if we do the natural log. And in parentheses here, let's go to functions and nth root here. The cube root of, we'll go e squared, is 0.6 repeating, which if we click on this will give us the 2/3. So All right, part E, we have log of 0.001 or log base 10. Since it was not written there, it's assumed to be base 10 of 0.001. We could evaluate this in our calculator, but just to kind of give you an idea of why the answer is the way it is, 0.001 is 10 to the negative third power, and here we have log base 10 of 10 to the negative third power. So once again, when the base of our logarithm matches the base of our exponential expression, then the answer is going to be whatever's in the power, which in this case, what do we have to raise 10 to get 10 to the negative 3? We have to raise 10 to the negative 3 power to get 10 to the negative third power. So log of 0.001 is negative 3. And again, if you typed in log 0.001 in your calculator, it should give you back negative 3. Part F, log, or 2 to the log base 2 of 8. Well, let's look at this expression here, log base 2 of 8 in the power. This means what power do we have to raise 2 to get 8? So what power do we have to raise that 2 to get 8? We have to raise it to the third power. So log base 2 of 8 is 3. So if we substitute that 3 in for our original problem, instead of having log base 2 of 8, we now have 2 to the third power, which is 8. And again, this is one of the properties we looked at in the last video, where if our base is being raised to a logarithm with the same base, assuming that what we're taking the logarithm of is positive, that will be our answer. So, but again, this is kind of an example of how that comes about. So, all right, part G, we have 117 to the negative log base 117 of 6. That's a crazy one. So remember, raising something to the negative power means 1 over that something to the positive that power. So 117 to the negative log base 117 of 6 is 1 over 117 to the log base 117 of 6. Well, once again, we have 117 to the log base 117 of 6. So because this base for the exponential function here matches the base of the logarithm, and this 6 is a positive number, then 117 to the log base 117 of 6, this whole denominator is just going to come out to be 6. So again, we can see that in a calculator here. So we had 117 to the negative log base 117 of 6, and we get 0.16 with a bar over the 6, which is 1/6. So, all right, that about does it for this video. Thanks for watching. I'll